Okay, so this is carrying on arithmetic sequences we started last lesson. All we've done so far really is just make a note of some notation. We're having A for the first term, N for the number of terms there are in the pattern, D for the common difference, that's how much they're going up each time. Like for our geometric ones, we'll use Sn will be the sum of the first n terms. So that's nothing new. That's the same notation as we used when we did geometric ones together. And un would be the nth term. So again, that's not new. That's what we've been familiar with before as well. So in the sequence we've got at the top of the board, the one that goes 5, 19, 13, 17, 21, the fourth term up there, which I denote U for, that is 17. Can anybody tell me how I could have got to that 17 without going through all of the 5, the 9 and the 13 beforehand? Think back to when we did GPs and we had a formula for the nth term. Yep.
5 add 4 to the power of 3.
Right. The power thing, that was when we were timesing. That was with the geometric progressions, the GPs. We're not timesing here, we're adding. So you've got to adapt what you said.
Add 4 to the power of 3.
Well, it's going to be 5 add. Right, just think, what are you adding to 5 to get 17?
12.
Right, so whatever you tell me now has got to be 12. So where could that 12 have come from?
3 times common difference.
3 times the common difference. That's correct, it is. Because we made 3 jumps to get there, and each jump was the common difference. So that's good, Laura. It was 3 times the common difference. So that 5 is the first term. That 4 is the common difference. And that 3, how's that 3 related to anything? Is n take 1? Yeah, it's the fourth term, had 3 jumps. So it's a plus n minus 1d is the formula for the nth term of an arithmetic progression. So that's the equivalent one of the a r to the power of n minus 1 for the geometric one. So that's the formula for the nth term. So for this number pattern that's still at the top of the board, if I wanted to know what the 10th term was, if I in other words wanted to know U10 without going all the way through the list, it's just going to be a plus n minus 1d. It would be 5 plus 9 lots of common difference. And 9 fours are 36 plus 5 is 41. So I could tell here that the 10th term would be 41. So what we're going to look at next is the adding up of these. And we're going to get a formula for S of n, the adding up one. I'm just going to do it by showing you where the formula comes from. You haven't got to be able to prove the formula or anything, but I'm going to show you where it comes from, and then we'll have the result, and that result you need to be able to use. So I'm going to look at a different set of numbers to start with, just to make things easy. Just looking at the numbers 1 up to 8 added together. Okay. I've missed out 6. There we go. 6 was meant to be in there. So the numbers from 1 to 8 added together. It's one of the most basic arithmetic progressions. You've got the first term is 1 and the common difference is 1. I'm going to call that then S8. That is the sum of my first 8 terms. Now, I'm going to write that down backwards. I'm going to sort of try and line it up and try and not forget any numbers this time. Do we all agree that that is also the sum of the first 8 terms? Okay. Now what I'm going to do is I'm going to add those 2 lines together like an adding up sum. So what is S8 plus another S8? It's 2 lots of S8. What is 1 plus 8? What is 2 plus 7? What is 3 plus 6? They're all going to be 9, aren't they? All the way up to the end. Now, how many 9s do I have there in that list? 8. Okay, so I've got 9 is there 8 times, and that's equal to 2 S of 8. So if I wanted to know what the sum of my first 8 terms were, if I just move that 2 from over here, where it's a timesing 2, to over here, excuse me, where it's a dividing 2, I'll have the answer to the sum of those first 8 terms. So that would be 72 divided by 2, that would be 36. So if you can follow that way, with that simple example, what we're going to do now is try and do one with not 1, 2, 3, 4, 5 and 6, but A's and D's in it. So I'm going to try and repeat that process now, and I'm going to have my sum of my first n terms, starting off with A as my first term. What would my second term be then, if I'm just doing sort of general term? Not A plus 1, think what's A plus D will be my second term. And then what would my third term be? Someone said it? A plus 2D. Thank you, Bethany. Yep. And I'm going to add these terms together. What would my very last term be? What would my last term be?
Really?
I didn't hear what you said.
A plus infinity.
No, we're having n of them. We're not going on and on forever.
Oh, n d.
You're nearly there, but
N
look.
take 1d.
Yeah, n plus, that's right. A plus n minus 1 lots of d. Now, first time I did this up here, what did I do after I wrote it out like that? What was the next thing I did up the top in that last example? Reversed it, yeah. So here, I'm going to write down my last term. Then I'm going to write down the one before my last term, the penultimate term. What would that one be, my penultimate term?
N take 2d.
You'll need it. A plus n minus 2 lots of d. That's what that would be. Okay. Then up towards the end, I'm going to have A as my very last one, and the one before that will be A plus d, and that is also equal to S of n. Now I haven't lined this up brilliantly here. Let me get another colour pen a minute. Ideally I'd have lined this up nice and neatly in columns. That one goes with that one. That one goes with that one. That one goes with that one, so on. Okay. So I did my page wasn't wide enough for me to do it. Because what I'm going to do now is just so before I'm going to add those together. So if I add those two rows together, that will give me 2 lots of S of n. I'm going to do it column at a time. So this side of that green line, what is A plus n minus 1d? 2a plus n minus 1d, that's correct. Okay, that's a 2sn there. Okay, so that's that first column. Now over here, in this column here, which is these here, I've got a plus d plus a plus n minus 2d. What have I actually got there then? Yeah, well, I've certainly got 2a, haven't I? There's a there and an a there, so I've certainly got 2a. Then I've got n minus 2 d's here and another d up there. So n minus 1d, yeah. Because I'm going to run out of room if I go across here. It is a continuation, I'm just going to run out of room. Okay? Because I had my 2a's, I had n minus 2d's here, then I had another one here, so that takes me up from n minus 2 of them to n minus 1 of them. Then the very end, I just put my sort of dot here. What am I going to get when I add these very last two together here? Yeah, I've got an a there and an a there, so it's 2a, and I've got an n minus 1d. So just like last time at the top, well, they all became 9s, they've all become the same thing this time. And how many of these identical terms do I have in this list? I have n of them, yeah. Like when I had 8 numbers added up, I had 8 of them. Here I've got n of them. So over here, that adding up is n lots of 2a plus n minus 1d. And that is what 2 lots of s of n equal. which means 1 lot of S of n is that divided by 2. In other words, n divided by 2 into 2a plus n minus 1d. And that is the formula for the sum of the first n terms of an arithmetic progression. It's given to you in the formula book, but if you learn it, then that's very useful.